This is a 64-bit virtual memory address. We start by converting it into its binary representation and marking the first and last bit position. Next, we strip out the unused bits, leaving us with 48 bits of valid address space. These 48 bits are then divided into 5 parts, following the layout shown in the diagram. From the diagram, you can see that each process ICR 3 register points to that process directory base, also called the DAR base. Let's take the system process as an example. We'll first inspect the system process information. Then switch into the system process context. Once we're in the system context, we can check the current value of the CR3 register. At the beginning of the video, the virtual address we're using is the starting address of the ZW create file function in the NT module. Now, we calculate the index for each paging structure entry. Note that this is an index, not a byte offset. If we need the actual offset, we multiply the index by the entry size, which is 8 bytes. Since CR3 points to the PML4 table, we start there. We compute the PML4 entry and read its value in hex. That value gives us the PDPTE address. According to the diagram, the lowest 12 bits are flag bits. Once we clear those, we get the physical base address of the PDPTE. We then take the PDPTE address, add the entry index times 8 bytes, and that gives us the PDPT. Reading the PDPT contents gives us the PDE. Again, we clear the lower 12 bits to get the base address of the PD. Next, we take the PD address, add the entry index times 8 bytes, and we get the PTE. After reading the PTE value, we inspect its binary representation and notice that the large page flag is set to 1. We clear the flag bits to extract the page frame number, commonly called PFN. Since each page is 4 KB aligned, we shift the PFN left by 12 bits, because 2 to the 12th power is 4 kilobytes. Then we add the byte offset within the page. And that gives us the final physical address. Now, let's take a look at the assembly bytes for the ZW create file function. We read the memory contents at the virtual address. Then read the contents at the corresponding physical address. As you can see, the two match, confirming our translation. And if you're using WinDbg, there's an easier way to confirm this. The exclamation PTE command shows you the page frame number. Exclamation V to P command walks through each level of the translation and shows the computed physical address at each step.